Today we're going to look at our first advanced technique for integration, and it's called the substitution method. What the substitution method is basically a reverse engineering of the chain rule. So what the substitution method does is it undoes the chain rule when you take derivatives. So to begin, let's take a quick refresher look at the chain rule. So if I have a function y is equal to f of u of x, and I want to compute its x derivative, so that's dy dx, I start by taking the derivative of f, so it's f prime evaluated at u of x, then I multiply that by u prime of x. So when I integrate this, I would integrate something like dy dx with respect to x in order to get to y. So I would end up multiplying both sides of this equation by dx. And so when we do that, we would have f prime of u of x times u prime of x times dx. Now u prime of x times dx is called the differential of u. So this is the differential of the function u. So we would say that du is equal to u prime of x dx. So this is how the differential of u plays out relative to x. It's basically almost the same as saying du dx is equal to u prime of x. So that's how the notation works. So the substitution method comes into play when you're trying to compute antiderivatives of the form integral of f of u of x times u prime of x dx. So basically it takes a form like this. So we have f of u of x times u prime of x dx. And what you do is you substitute variables. Instead of integrating with respect to x, instead we integrate with respect to u. So we basically define u is equal to u of x, and we replace the combination u of x where we see it. So this integral becomes the integral of f of u du. So our du is the u prime of x dx. So let's see an example to see how this really works. So suppose we have the integral of cosine of x squared times x dx. So if we're looking at this, we're going to see cosine of x squared as an f of u of x. So the inside function, which is the x squared, is what we want to identify as our function u. So we would set u is equal to x squared, because by doing this, cosine of x squared would become just simply cosine of u. And the other reason we choose x squared is we see the x sitting outside of the cosine of x squared, but with inside the integral, and x is basically the derivative of x squared up to an additive constant. So with this identification that u is equal to x squared, our differential du is going to equal 2x dx. So when you write the differential of u, so when you go from u is equal to x squared to du is equal to 2x dx, all you do is take the derivative, except you call the left-hand side du, and then you take the derivative of x squared, which is 2x, and then you multiply it by dx. So du is equal to 2x dx. Now we almost have the du inside the integral right here, except we're missing the 2. And that's okay. So whenever you are missing a constant factor, you can take care of it by doing the following. So you can multiply the inside by 2 divided by 2. Okay, now 2x dx is sitting right there, and I have an extra factor of 1/2. So let me pull out the 1/2, and then we have the integral of cosine of x squared times 2x dx. Now 2x dx is my du, and the x squared is just u. So this integral, once we apply the substitution, becomes 1/2 the integral of cosine of u du. So basically, instead of integrating with respect to x, we're focusing on this u, the inside function, which is x squared, and we're integrating it with respect to u. So we can integrate cosine of u with respect to u because we have the derivative of u sitting right here. So 2x dx by itself forms the du. Now the integral of cosine is equal to sine. So remember the derivative of sine is cosine, so the integral of cosine is sine. So this becomes 1/2 sine of u plus c. And then the final step is we substitute back in u for u of x. So u is equal to x squared. So what we get in the end is that the integral of cosine of x squared, x dx, is equal to 1/2 sine of x squared, and then plus c. When you're done, you can check. So take the derivative of the right-hand side. The derivative of 1/2 sine of x squared, well, the derivative of sine is cosine, so this sine turns into a cosine. So we get 1/2 cosine of x squared times the derivative of the inside. The derivative of the inside is 2x, so we multiply this by 2x, and we get x cosine of x squared as the derivative of 1/2 sine of x squared. So that works out just fine. So you can really see that what we're doing is we're undoing the chain rule when we do this. So we identify the inside function u of x. The only hitch is that we need the derivative of the inside function sitting within the integrand up to a constant multiple in order to pull this off. Right? So another example would be the integral of e to the minus x squared times x dx. So here we can make, well, we have a choice. We can set u is equal to x squared or minus x squared. You get the same answer either way. But you just have to be consistent and stick with your choice. So let's use minus x squared. So let's say that u is equal to minus x squared. So therefore du, derivative of minus x squared, is minus 2x times dx. Okay, so I have basically my x dx sitting right here in the integral. So x dx is equal to du over minus 2. So when I do my substitution, it's e to the u, because u was equal to minus x squared. X dx is equal to du over minus 2. So then we have du, and then I'll just write minus 1/2 outside. Now you can move stuff around in this equation as long as you don't move anything with an x around, right? So you don't want to replace, what you replace your dx with, and maybe some guys in here, can only be a function of u. So you have to have this, the integral only depend on u. There can't be any x's left, whatever you do. So we have minus 1/2 integral of e to the u du. Well, we know that that's minus 1/2 e to the u, and then plus c. Now we can replace u with minus x squared, and then plus c. So therefore we obtain the integral of e to the minus x squared times x dx is equal to minus 1/2 e to the minus x squared plus c. And we can check by taking the derivative. So if we take the derivative of the right-hand side, so the derivative of minus 1/2 e to the minus x squared is going to equal, okay, well, we rewrite it. It's an exponential function, so the first step is to rewrite it. Then you multiply by the derivative of the exponent. So the derivative of minus x squared is minus 2x. So we multiply by minus, so that's going to cancel this out. 2x, the 2's cancel, so the derivative is just x e to the minus x squared. And that was the integrand that we started with. So the whole thing works. So that is how to use the substitution method.